We have a lot of educational content here at zebX. So we have our decarb lunches, and CLF British Columbia also has its own suite of webinars, which are all free to attend. So if you're interested, do check out the zebX website, which lists all of our events. And so what we're here to talk about today, what is embodied carbon? Embodied carbon is everything, all of the emissions to do with extraction, processing, transport, and the construction of a building. So then the other kind of portion of that emissions full life cycle is the operational emissions and building upgrades. Building upgrades are also kind of a material extraction and construction related emissions. So they are also included in our embodied carbon assessment of a building. So when we're talking about embodied carbon, we want to know what the upfront emissions is, what are the emissions associated with building a building, and what are the emissions associated with replacing components in a building. So there's also kind of a lifespan component to embodied emissions. If you're using something, a component or a membrane that only has a lifespan of 5 years, you're going to go and need to replace that quite often. So that will have a bigger carbon footprint over its entire life. So highlighted in red here is the portion of the emissions that we're looking at when we talk about embodied carbon. And so typically when we're talking about embodied carbon, we are talking about the structure, the foundation, the siding, the insulation. There are a lot more pieces that actually contribute to the embodied carbon of a home. There's not a lot of information about things like lighting or mechanical equipment or internal finishes. So when we do an embodied carbon assessment of a home or a building or a bridge or whatever it is, we typically limit the scope to things like the structure, envelope, foundations, and insulation. And we know that those are the big hitting components in a building. And so just for anyone who really wants that neat and tidy definition written down, the carbon emissions associated with materials and construction of a building, including replacement of parts throughout the lifetime and demolition at end of life. So a big component of the embodied carbon of a building is the decomposition of those materials in landfill. So really thinking about what you're doing at the end of life of a home is a big piece. And just shown out here on a graph, we've got embodied carbon in dark blue and operational carbon in the lighter blue. And you'll notice that we're flipping between carbon and emissions. They mean the same thing. So you'll see it written down as embodied carbon. You'll see it written down as embodied emissions. It doesn't even depend on the country of origin or where your speaker is coming from. People are using these interchangeably. So over the lifespan of any building, you've got a big chunk in the blue on the left of embodied emissions right at the beginning as you construct the building. Then over the lifespan of the building, you've got the operational emissions. Every now and again, you do some repair and maintenance, and then you've got another quick blast of embodied carbon or embodied emissions. And then at the end of life of a building, you will also have another chunk of embodied emissions associated with the demolition and recycling or landfill or whatever you choose to do with that building, or whatever somebody else chooses to do with your building. And so why do I care? Tony mentioned that I was a structural engineer. Predominantly, I've spent most of my career in the large buildings world. This building on the right is one of my first buildings that I worked on in London in the UK. And in the middle there is a picture of me looking quite happy. I am currently stood in the basement of the building on the right. And what looks like a wall behind me is actually a 3-story deep steel beam. So those kind of little openings there are actually web openings through the steel. This is probably one of the biggest steel beams that I've ever designed. And there's not just one of these in the basement. There are something like 34 of them. And on the one hand, I'm pretty young and pretty chuffed that I have designed this and I'm holding up the whole building. But on the other hand, a little piece of me was thinking this is quite wasteful. You know, do we really need this type of construction? Can we not do this a better way? And so this kind of theme was with me throughout my entire career. You know, this seems a little bit wasteful. This seems a little bit wasteful. And I didn't really have embodied carbon as a lens. But actually, I realized, yes, we are being wasteful with not just resources, but those resources have a carbon footprint associated with them. So this has become my own personal kind of mission, I guess, to reduce waste within the construction industry, improve the way we design buildings so that we are more mindful about what we're taking from the earth and what we're putting into the atmosphere. And so embodied carbon quantified, what is the scale of this problem? Do you need to care? So provincially, well, this pie chart on the left, first of all, is global CO2 emissions by sector. So it's estimated that materials and construction globally are responsible for about 11% of all emissions, which is a pretty huge chunk. It's more than road transportation in most countries. Transportation overall is about 22%, but that includes things like aviation and shipping. So when you're listening to politicians saying that you need to stop driving your car or you need to drive less, remember that actually the material or the carbon footprint associated with your work is as big, if not bigger, than road transportation. And so provincially on the right, I've just got some statistics from BC. So every year in BC, we emit roughly 63.5 megatons of CO2 equivalent. Embodied emissions, roughly 7.2 megatons, so 11%, very, very, very similar to the global estimate of embodied emissions. Operational emissions, 8.3 megatons of CO2 equivalent. So they are incredibly similar. But what is important to remember is that we are very, very far ahead in the operational world. We have done a lot to improve our understanding of our operational emissions, and we are retrofitting and improving the way we design buildings every single day. So operational emissions is trending downwards at a very, very fast pace. Embodied emissions, we haven't quite got there yet. So if we want to get to our 2030 and 2050 goals, we really have to start looking at embodied emissions. And this kind of very, very small graph here is a graph by Priopta showing the building stock in BC. So each kind of chunk of this chart shows a different type of building, excuse me. So over on the far left, those very, very tall columns, that represents single family homes across the province. And then the next group over is, you know, attached single family homes, and then we've got apartments, office buildings. So we're looking at how much we're building and how much of the building stock we already have in different types. And single family detached homes are by far the biggest building stock, the biggest component of the building stock here in BC. Red shows the existing buildings, green shows projected construction in that building type between now and 2050. So any decrease in red is the demolition we're expecting between now and 2050. And any increase in green is what we're expected to build between now and 2050. So we're demolishing a huge amount of the homes that we have in BC, and we're also building a huge amount. So it's really important. It wasn't until I saw this graph that I realized how important homes are in BC, not the big buildings. It's important that we get to grips with the embodied emissions in the single family homes that we're building. And then just to come at it from one more angle, what is the embodied carbon with lots of different things that happen in our daily lives? So we've got a flight, London to New York. These statistics are a few years out of date now, so potentially slightly off. just less than a ton of CO2 equivalent to fly between London and New York. About half of that for 1 meter cubed of 35 MPa concrete, but as many of you know, 1 meter cubed doesn't go very far. Cutting out meat, dairy, and beer for a year, roughly 2 tons of CO2 equivalent per year. I don't know how much of that you could hear, but the dog walker is here now, so she's quite excited. And then right at the far other end of the scale, thank you, all of the transfer beams in one library, 642,000 kilograms or 642 tons of CO2 equivalent in just one library. So this is when I really started to see the scale of impact that I could have in my professional life as compared to my personal life. You know, I stopped flying, I cut out meat and dairy, but actually I could have a much bigger impact if I focused on reducing my carbon footprint at work. And I'm hoping that everybody here on the phone call today who's potentially sustainably minded, might be starting to see the same thing. So how do you find out what the carbon footprint of your materials are? Well, for one, or one great source is the EC3 database. And this is a screenshot. The EC3 database is free to use. Anyone can sign up. And this is just a screenshot of the homepage. So you go in here and you can click on material type, concrete, masonry, steel, whatever. And I've just grabbed 3 here, and coming from a structural background, I picked 3 structural materials. So you can see, concrete and glue lamp should both be in meters cubed. Steel should be in kilograms. So you can see there's a whole host of information that you can use to get started in estimating the embodied carbon of the projects that you're working on. So what could you do about it? Well, first of all, we have the near zero embodied emissions, which is stream 2 of near zero. And this is a research program that we're running at zebX, specifically targeting homes being built in Vancouver. And we're wanting to find out about the experiences of designers and builders as they work towards reducing the embodied carbon or the embodied emissions of the projects that they're working on. So this slide also is slightly out of date. We also have stream 4 now. So stream 1 was a program from 2019 that focused on operational emissions. I'm running stream 2, which is the embodied emissions component. Stream 3 was the domestic hot water program. And we have a 4th on the way. So what is the program? In a nutshell, reduce the embodied carbon of your home. Tell us about it. Tell us what your successes were, what your failures were, what the biggest hurdles you overcame were, and we will offer up to $40,000 in funding for that knowledge. And what we want here is to be able to build educational content for other designers and other builders in Vancouver. We want to know about, you know, how much can we reduce embodied carbon in homes today without, you know, oodles of research and oodles of research funding. We want to know what the easy wins here that we can tell people about. So we're hoping that people will go out there, try some ideas that we have, some proven methods from other builders, and just tell us whether they are able to achieve this. I believe people are, just we want the evidence to back that up. So eligibility requirements, the eligibility to be eligible, the project must be within the city of Vancouver and designated as a Part 9 building. And the project must either be in design phase currently or early construction phase. So what we've said for early construction phase is you can be doing the foundations on site, you could be doing the basement or excavating, but as soon as you start building up above the ground, you're probably too far to really contribute to the program. There's not a lot of changes that you can make beyond that point on site. So that's the line that we've drawn in the sand there. And we have some reduction targets. So if anyone follows Builders for Climate Action, they published a material emissions benchmark report for homes in Vancouver last year, and they assessed some as-built drawings for something like 10 or 15 homes within the city of Vancouver. They assessed the embodied carbon and found that on average, a home in Vancouver has a carbon footprint of approximately 200 kilograms of CO2 equivalent per meter squared of heated floor area. So what we have said here is if you're able to reduce the embodied carbon of your home to less than 40 kilograms of CO2 equivalent per meter squared, we'll give you that maximum incentive of $40,000. And we've got a couple down at 20, so we know this is possible. We also know that the average in Vancouver is 200. So within this material emissions benchmarking report, there were homes down at the 120 mark, and they didn't even try. So we know that it's pretty easy to get up into the $15,000 bracket, and then increasingly difficult to nudge between $15,000 and the $40,000 mark. Actually, just to go back one slide again, the material emissions benchmark report is available on the Builders for Climate Action website. And in that report, they talk about different ways in which people have reduced the embodied carbon of homes in Vancouver. The Builders for Climate Action website in general is a great place for resources. So I do encourage you to check it out if you're interested. So the application process, I'll skim over this because if you choose to apply, you'll receive this in your welcome email as well. But just to lay it out really quickly, you register for the program, which you can do on our website, nearzero.ca. We then give you free training in the BEAM tool, which is a Part 9 oriented tool that people can use to assess the embodied carbon of single-family homes. You then go away and try out some low-carbon design ideas. And once you have completed the design of the home, you will then carry out a BEAM assessment of that home and submit it to us. Builders for Climate Action are partnering with us on this research program, so they're going to be reviewing all of the calculations for this work, which is great. And once they have reviewed and said, yep, these guys have ticked all the boxes, I will then send you a questionnaire. So we'll have 2 questionnaires. We've got a design phase questionnaire and a construction phase questionnaire. In the second phase of the project, you build the home. There's going to be changes, there always will be, and there's going to be problems on site. And so we want to know about things like that as well. At the end of construction, we do a second BEAM assessment just to capture all of those changes. And then once Builders for Climate Action have reviewed your assessment number 2, I will send you a second questionnaire and just ask you about the lessons learned during the construction phase. And then that's it. Then we send you the money. There is actually a partial payment given out between the design phase and the construction phase as well. So what do we currently know? I've actually skipped ahead of myself. So this is the material emissions benchmarking report. So actually, I'm just going to gloss ahead here. So the City of Vancouver, the only thing I will touch on is the City of Vancouver's climate action plan is to reduce embodied carbon in buildings by 40% by 2030. And so this material emissions benchmarking report is really helping the City of Vancouver say, okay, well, if we want to reduce it by 40%, where are we currently at? And if we just go back a second, actually, 40% puts you in the $15,000 category there. So if we want to meet our 2030 goals today and earn $15,000, you can participate in this research program. So these are the homes that were included in the City of Vancouver benchmarking report. So you can see we've got this one in the middle here at, sorry, the numbers on the far right are the embodied carbon per meter squared, and these are ordered by embodied carbon. So this top one here is the worst performing at 357. 200 was taken as the average. The actual average they found was 193. We just rounded that up. So a lot of these homes will have been earning money if they were to participate in the research program. And Builders for Climate Action have studied the homes that we're building in several different cities now. So on the left here, we've got an EU benchmark, not done by Builders for Climate Action, but they have done the Nelson, Toronto, and Vancouver benchmarks. And what they're finding is the average in each of those cities is around the same point. So 150 in Nelson, 190 in Toronto, and 193 in Vancouver. So we're pretty confident that this baseline is consistent. And what they do have on their website as well is from all of these studies that they have been doing, they have collected information on what the worst performing buildings use, what the best performing buildings use, and what the average building uses. So if you want to say, figure out how you might be able to swap out some of the products that you're using on your designs, this is a really great place to start. One of the things that's appearing most consistently is the biggest contributor to the embodied carbon of a home is the concrete. And so we're talking about basement and foundations. The second biggest contributor is insulation. So there are two different kind of approaches to dealing with these. Concrete, there aren't too many alternatives to concrete, especially for basements. So the strategy for reducing the embodied carbon associated with the concrete in your home is one of two things. Either specifying a low carbon concrete, and we're finding that home builders in particular are finding it difficult to source a low carbon concrete. The other alternative is to reduce the volume of concrete that you're using on your project. So that's moving space above ground, eliminating basements, or eliminating some of the basement volume, and switching out foundations. So some of the most the lowest carbon buildings that we're seeing are eliminating the basements entirely and swapping the generic strip foundations to pier foundations, which use a lot less material but do the same thing. They take the loads from the home and put them in the ground. Insulation, however, there's not too many ways that you can reduce the volume of insulation that you're using on the home without doing things like building a box instead of building a profiled building. So insulation, we know that the best way to reduce the embodied carbon associated with insulation is to choose a low carbon product. And we're seeing more and more products on the market that have a much lower carbon footprint, are typically plant-based in some descriptions, so wood fiber insulation being one of those, and swapping out the foamed products for a natural alternative is the best way to reduce the carbon footprint with insulation. And the same is true for things like interior surfaces. Windows is a bit more challenging. The embodied carbon associated with glass is quite high. So there's a mix here of minimizing these materials that have the highest carbon intensities, minimizing the volume associated with those, and then swapping out the products to lower carbon alternatives. So the minimizing route, you're using less materials, and often you're building less on site. So going down the minimizing path is going to save you time, and it's going to save you money in materials on site. So we know that this is a way to reduce embodied carbon and also to save yourself money. However, swapping for alternative materials can be cost neutral, but it can be more expensive. So we know that not all of these low carbon products are at the same price point as traditional products. So there are two approaches, and I would strongly kind of encourage the first approach, the kind of minimizing materials where you can, eliminating a basement on site if possible, can save a huge amount in construction time. So that is definitely the most cost-effective route to minimizing embodied carbon. And I've kind of touched on this already, but this is an image from the MIStructE in the UK, the Institute of Structural Engineers, and this is their hierarchy of change. So the wider the segment of the triangle is, the bigger the impact that you can have. And so the biggest impact, or the biggest way you can reduce embodied carbon, is to use less stuff. And in general, that might mean reusing buildings rather than demolishing them, or reusing parts of buildings that have been deconstructed on site, and then just being more efficient with the materials that we are using. So using pier foundations instead of continuous strip or pad foundations. Slightly smaller segment of this triangle is specify low carbon. If you're specifying low carbon, you're still using some carbon. So it's always going to have a smaller impact than just using less stuff. But it is a great way to reduce the carbon footprint of a home. And then what we can't reduce and we can't specify an alternative for, the last kind of piece of this hierarchy is to offset. And so ultimately this was kind of written with how to get to net zero. We're not aiming to get to zero right away, only aiming to get to a 40% reduction by 2030. So we can sit in these kind of top two pieces of this triangle. Ultimately, we're still going to build homes, and we're still going to build other buildings. So that's when things like carbon capture and storage and offsets come in. So this is where I think we are in industry right now. The people who are ahead of the curve and who are already kind of looking into reducing the embodied carbon of their projects are typically going down the route of specifying low carbon. And that's getting them some way, but there is a whole host of the triangle up above that we can move into. The City of Vancouver have their own carbon pollution plan. So the aim is to get to 50% in general across the city by 2030. The target is 40% for buildings, with the aim of being completely carbon neutral by 2050. So one of the things that they are doing for larger buildings is introducing regulations. So for Part 3 buildings starting in September this year, any new building going through the building permitting process must submit the embodied carbon associated with that building. There are no targets just yet. Targets will start in 2025. At the moment, they just want you to calculate the embodied carbon and submit that with your building permit application. And those targets for those Part 3 buildings are going to steadily get harder and harder to meet as we move towards 2050. So they've already done this for Part 3 buildings and have indicated that they are planning to do the same for Part 9 buildings at some point. And some of this research, the City of Vancouver are funding this research program, and some of that is to give them some knowledge as they think about what those regulations might look like for homes in Vancouver. And this is one case study that we published on our website recently of a home in Nelson with material carbon emissions of 22 kilograms of CO2 equivalent per meter squared, so way up in the $40,000 brackets. It's a small home, just 53 meters squared. The total, sorry, these two graphs here, I'm just reminding myself, the yellow one is material carbon intensity, so in kilograms of CO2 per meter squared. The blue graph at the bottom there is in tons of CO2 as an absolute number. So in Nelson, they found that the average home took about 150 kilograms of CO2 equivalent per meter squared. So this 22 is way down in the bottom 15%. However, because it's such a small home, if you take things in absolute numbers, it is in the bottom 5% of homes, or is, sorry, 5%, 4% of an average home in Nelson. So they achieved step 5, which is great. Some of the people who advocate away from embodied carbon argue that, well, we want these homes to be heavily insulated, so we can't possibly reduce our carbon footprint. But this home is telling us, yeah, we can achieve step 5 with an incredible operational performance, and we can still lower our embodied emissions. It's a wood frame home. There's no basement. This is one of the biggest ways that they reduced the embodied carbon of this home, and they've used cellulose insulation. So they had 3 key strategies: minimize concrete, use carbon storing materials, and then swap out for low carbon alternatives. Minimizing concrete, I kind of suggested a couple of these already. They swapped out their traditional foundations for pier foundations. They completely eliminated the basement. Pier foundations use significantly less concrete than traditional foundations. They also eliminated the ground floor slab and swapped this out for a suspended wood-framed ground floor. So eliminating the basement, they estimated that that saved them for this project 10.7 tons of CO2 equivalent, which is pretty huge. And swapping out the foundations and the suspended slab instead of a ground floor slab here estimate to save them on this project 5.3 tons of CO2 equivalent. These are quite high numbers. One of the reasons is because they couldn't source a lower carbon concrete in Nelson, so the carbon emissions per meter cubed of the concrete there is quite high. Carbon smart materials. So instead of using foamed or EPS type insulations, they have used cellulose insulation and a staggered stud wall here. So they needed to increase the thickness of the wall to use a cellulose insulation. So this staggered stud solution, he said, was probably the hardest thing about the project. And they also introduced this at quite a late stage. So they were doing a lot of these modifications on site. So this, he estimated, added 1 to 2 days in construction time, but they estimated they saved about 2 weeks of construction by eliminating the basement. The cellulose insulation is a recycled plant-based product, so it's actually carbon negative, carbon storing, which really helped them out. Additionally, they used some locally sourced cedar siding, which had a very low carbon footprint, instead of using things like party board, which has a very high carbon footprint. So the use of cellulose insulation saved about 1.3 tons of CO2 equivalent, so much less of an impact than doing things like eliminating the basement. Use of cedar siding, they estimated to have saved 1.7 tons of CO2 equivalent. So yeah, really down in the very bottom bracket of this. And I don't remember right now exactly what the cost savings were, but this project came out financially better off and with a much lower carbon footprint than they would have before they started implementing these changes. So the Nelson Laneway had a 96% reduction relative to an average home in Nelson. Most of that was in eliminating the basement, and the other substitutions that they did got them down to about 13.8 tons of CO2 equivalent. A lot of the savings that they got here were because of the size of the home. They really minimized the square footage intentionally as a method of reducing embodied carbon and reducing the operational demand as well. Good. We've got the cost numbers that I couldn't remember here. So they saved 14 days of construction, predominantly in the basement. They estimated to have saved about $25,000 in materials cost and about a 90% reduction in embodied carbon. So just this again, so a reminder that by moving from this kind of specify low carbon world that a lot of people are working in right now, and up into the use less stuff world, we can really see the biggest savings in embodied carbon. So that's me. That's the Near Zero program in a nutshell. If you are interested or want to learn more about this program, we've got a dedicated email address. You can also check out the website nearzero.ca, which has more information. And if you do register with the program, we do provide additional training on both embodied carbon in general and the BEAM tool, and so how to calculate your carbon footprint. And that's that. Yeah, I'll hand it back.